Hello everyone. So here we are going to solve MCQs from test GP 2235, which is on carboxylic acid and its derivative. First question is N-butyl benzene on oxidation with KMnO4H plus gives. N-butyl benzene is what? CH3, CH2, CH2, CH2 with phenyl. So this is N-butyl benzene. By using KMnO4 as an oxidizing agent, what will happen? This CH2 gets oxidized into acid and we will get C double bond OOH as a main product, which is nothing but the benzoic acid. So the answer is option B, benzoic acid. Next question. Identify product D in the following reaction CH3Cl. Okay, I'll show the reaction. First, CH3Cl is treating with the KCN. We are getting A. When this A is treated with H3O plus, we are getting B. When it is treated with the NH3, we are getting C. And when it is treated by heating, we are getting D. They are asking for D. Our starting material is CH3Cl. So when CH3Cl reacts with KCN, what will happen? It is simple. KCN, what will happen? It becomes CH3Cn. Right? So this is our A. When we treat with H3O plus, what will happen? It becomes CH3. Cn gets oxidized into C double bond O, OH, right? So this is our B. Then B is treating with ammonia. What will happen when it is treating with ammonia? It will get converted into CH3, C double bond O, NH2. Okay. And after heating we are getting D, but normal heating do not degrade amide. Okay, so finally we will get CH3 C double bond O NH2 only. Okay, which option is this? CH3 C double bond O NH2. Option D, CH3 C double bond O NH2. Next question. Which of the following reaction does not lead to formation of acetic acid? Acetic acid is what? CH3 C double bond O OH. Let's see. When we treat ethanol with K2Cr2O7, what will happen? It gets converted, it gets oxidized into CH3 CH C double bond O OH, which is nothing but the acetic acid. This is the oxidizing agent, right? The next, it is malonic acid. So when we heat it, simply what will happen? It gets converted to CH3 C double bond O OH, that is acetic acid. When we hydrolyze it, when we hydrolyze the methyl cyanide, so as we saw in previous reaction, when methyl cyanide is treated by the when we do hydrolysis of methyl cyanide, it gets converted into acid, that is CH3 C double bond O OH, which is nothing but the acetic acid. This is oxalic acid and they are reacting with glycerol. Glycerol is what? CH2OH, CH2OH, CH2OH. So when we treat oxalic acid with glycerol at 370 Kelvin temperature, what we will get? We will simply get this. This is, see, double bond is here. It means it is allylic alcohol. So you can see the fourth reaction does not lead to formation of acetic acid. So the correct option is correct answer is option D. Next question. This is our reactant. We are doing acid hydrolysis. What will happen? This C double bond O gets converted into, let's see, this CH3 will remain as it is. This one also remain as it is. Instead of C double bond O, it gets converted into COH and COH. Okay. After that, what will happen? Now, what will happen? This bonds gets break and we will get this CH3, this CH and OH. So CH3, CH, OH. Okay. Now this carbon atom is attached with this oxygen atom, which is attached with CH3. Now this carbon gets converted into COOH because it is having two hydroxy group. So this oxygen is with CH3 and it is with COOH, which is nothing but this group. Okay. Now, and this oxygen with one hydrogen. It is having positive charge. This bonds gets big and shifted into this. So what we will get? CH3, CH with positive and OH. Right? And the another one is this. That is OH, CH, CH3 and this is with COOH. This is CH, not CH3. Okay. Now what will happen? This will get delocalized and we will get CH3, C double bond O, H. Okay. And CH3, CH, OH and COOH. So we are getting these two products, right? Which option? CH3CHO is in this option, option B. Let's check with the second product, CH3CH, CH3CH with OH, OH, COOH. So the correct answer is option B. Okay. Next question. The formylating agent in Gattermann-Koch synthesis is. So the formylating agent in Gattermann-Koch synthesis is carbon monoxide. You have to remember this. So the answer is CO plus HCl or Lewis acid, that is AlCl3. Okay. Next question. Which of the following is correct? So the first statement is on reduction of any aldehyde gives secondary alcohol. If we are taking example of this aldehyde, CH2 C double bond OH. On reduction, what will happen? Reduction of this, so we will get CH3 CH2 CH2 OH. This carbon atom is only attached with one carbon atom. It means it is giving primary alcohol and they are saying secondary. So this statement is false. Second statement, Reaction of vegetable oil with H2SO4 give glycerin. So reaction of vegetable oil with H2SO4, it gives glycerin. No, it gives unsaturated fatty acids. Okay, so this statement is also false. Next, C2H5OH with iodine NaOH, it will give CH3 C double bond O H. Okay, and when we treat it again with iodine NaOH, then it will give HCOONA, that is sodium formate, plus CHI3, this is iodoform. So it gives iodoform. Yes, it gives. The last one is sucrose on reaction with NaCl give invert sugar. No, sucrose with NaCl does not react. So this statement is false. So which one is the correct? C2H5OH, that is ethanol, iodine with NaOH gives the iodoform. Next question. This treated with LiAlH4 we are getting A, and when A is treated with this we are getting B. We have to find out B. Let's see. So when we treat this with LiAlH4, excess of LiAlH4, what will happen? This Cn gets converted into CH2NH2. It gets reduced into CH2NH2. Right? And this ester is get also converted into the acid. And what we will get over here? This gets converted into acid. It means C double bond OH. This CH2 twice will remain as it is, CH2, CH2. This Cn gets reduced into CH2NH2, that is amine. Okay. After hydrolysis, acid hydrolysis, what will happen? Cyclization. See, 1, 2, 3, 4. 1, 2, 3, 4 with NH. Okay. So what we are getting? Option D. Right? Next question. This is ethylene. So ethylene with sodium liquid ammonia in excess, what we will get? This hydrogen gets replaced with sodium, this also. So NaC triple bond CNA. Okay. Then it is treated with DCl. So what will happen? Na gets replaced with D. CD triple bond CD. Then they are doing Lindlar's catalyst. So Lindlar's reduction. So Lindlar's, from Lindlar's we always get C sulkene, whereas by Birch trans-sulkene. You have to remember this. Now they are doing Lindlar's reduction. So hydrogen gets added from same side. So C with D, double bond C with D, and two hydrogens from same side. So what is the correct option? It is option C. C double bond C, hydrogen, hydrogen, and DD. That is deuterium. Okay, so the correct answer is option C. Next is, which of the following product may be formed in the given reaction? The reactant is this, and we have to treat this with this. Okay, so what will happen when we treat this with ETONA? Simply this Br gets attached to Na and it will be moved out as a NaBr, whereas the hydrogen from this carbon atom gets attached with this ETO and it will be moved out as a ethanol, that is ETOH, and here is formation of double bond, that is this. So which one is the correct option? Option C. Next question. In a set of reactions, acetic acid yielded a product D, CH3COOH, treated with SOCl2, we are getting A. When it is treated with benzene and anhydrous ZnCl2, we are getting B. When it is treated with cyanide, we are getting C, and when it is treated with H3O plus, we are getting D. We have to find out D. So the first is CH3, C double bond O, OH. When it is treated with sulfonyl chloride, SOCl2, simply this oxygen gets replaced with chlorine. So it becomes this. When we treat with benzene and anhydrous AlCl3, not ZnCl, AlCl3, what will happen? This chlorine gets replaced with benzene and we will get CH3, C double bond O, and phenyl ring over here. Okay, when we add cyanide in it, simply what will happen? It will get attack on this carbon and we will get carbon with phenyl ring. Here is CH3 and here is Cn. And at the end, what will happen after H3O plus treatment, acid hydrolysis, this Cn gets converted into COOH and simply we will get CH3 with COH, one phenyl ring, and here is COOH. So the correct option we have to find out, carbon with CH3OH COOH, carbon with CH3OH COOH. So the answer is option A. Next question. A racemic mixture of carboxylic acid having one chiral center is treated with the enantiomerically pure amine. The products form are. So racemic mixture which are having one chiral center and treated with enantiomerically pure amine. Racemic mixture, it means 50-50%, right? Enantiomerically pure amine, it means 100%, right? So what we will get? See, in this case, two esters will form, okay, and both of them will be diastereomers because the chiral part of the acid will not participate in the reaction, so product will be optically active. Okay, so the answer is option A, diastereomers, both optically active. Next question. Two ice cubes are pressed over each other. are pressed over each other until they unite to form a one block. Which one of the following forces dominates for holding them together? So for holding them together, out of these four, the hydrogen bond formation is dominates for holding them with each other. So the answer is option C. Next question. Which of the following is strongest acid? First is CF3COOH, fluorine, bromine, CH3 and chlorine. Okay. So on the basis of electronegativity, out of these four, the fluorine is most electronegative atom, and on the basis of this we can conclude that the CF3COOH is the most acidic one, strongest acid. The second will be chlorine. The third will be bromine. And at the end, CH3COOH. Okay. Next question. Consider the acidity of the carboxylic acid. So the first is benzoic acid, that is benzene with COOH. Whereas the second compound is orthonitrobenzoic acid, benzene with COOH, and on ortho position there is nitro. This one is the second one. The third is para-nitrobenzoic acid. So benzoic, and on para position there is nitro. This is the third one. And the fourth one is meta-nitrobenzoic acid. Benzoic, and on meta position there is nitro. So this one is the fourth one. Now we have to determine the order of acidity. Okay. So in first case there is only acid group, no substitution. Okay. And in second, third and fourth case, the electron withdrawing effect is due to the nitro group. So thus the acidic strength is increases, but the orthonitrobenzoate ion is stabilized by the which molecular? Intramolecular hydrogen bonding in this case. Okay. Hence its strength is maximum. So the acidic strength of the second compound is more. Okay. It also having the ortho effect. Right. Now out of these two, in meta there is steric inhibition. So because of here is no steric inhibition, they are totally opposite to each other. So the second one is third compound. After that, fourth compound. And at the end, the first, which is simple benzoic acid. So the order is in this manner: second, third, fourth and first. Second, third, fourth and first, option D. Okay. Next question. Thermosetting polymer bakelite is formed by the reaction of phenol with. So n number of phenol. When we treat it with n number of formaldehyde, that is HCHO, then we will get bakelite. This is the thermosetting polymer. This is bakelite. Here is CH2. Here is. Okay, so this is the bakelite. So phenol with formaldehyde. Option B. Next question. Ethanol cannot be concentrated by fractional distillation because the boiling point of ethanol with water is very close to each other, and the constant boiling mixture of ethanol with water is what? Azeotropic mixture, and this azeotropic mixture is boils at 78.10 degrees Celsius, and only because of this is uh, the fractional distillation is not possible. So the main reason it forms a constant boiling mixture with water, option C. Next question. Decarboxylation of isobutyric acid yield. Isobutyric acid is what? CH3, CH, CH3. This is iso because on second position there is methyl group. Isobutyric acid, decarboxylation of this. So decarboxylation in presence of NaOH and CaO, that is calcium oxalate. So what will happen? Decarboxylation. So it becomes CH3, CH2, CH3. This COO gets removed. This is nothing but the propane and plus Na2CO3, sodium carbonate. So the answer is option D. Next question. This is the calcium salt of anhydride. On heating, what will happen? See, this COO, Ca, this will removed out as a CaCO3, and this 4 member and this CO will form this 5-membered ring with keto group. That is option A. Next question. The compound that undergoes decarboxylation most readily under mild condition is. So beta keto acid are readily undergo. Beta keto acid are readily undergo thermal decarboxylation. So we will find out the beta keto acid. You can see this is the acid, this is the alpha carbon, this one is beta. On beta there is no keto. This is the alpha this is the acid, this is the alpha, this is the beta. On beta nothing. This is the alpha carbon, this is the beta. On beta there is acid. This is the alpha carbon, this is the beta. Here is oxo, it means keto group and acid. So this is the beta keto acid which undergo the thermal decarboxylation, and simply we will get this with double bond O plus CO2. So the answer is option D. Next question. Which pair of compounds on heating give the isomeric product? So first we will see this. So on heating, simply what will happen? The OH from this carbon and H from this carbon gets removed out, and we will get CH3, CH double bond CH, C double bond OH. Whereas when we heated this OH from this carbon and hydrogen from this carbon, and we will get CH3, C, CO2H, double bond CH2. You can see both of them are having same molecular formula, only differ in the structure. Okay, so This pair is having having the isomeric product. Next we will see for this, on heating, same, what will happen, the OH from this carbon and hydrogen from this carbon, and we will get CH3, CH double bond, CH CO2H. Whereas hydrolysis of this, what will happen, OH from this carbon atom and hydrogen from, and we will get the product, that is CH3 CH, not CH, only C with one CH3. It is having doubly bonded with carbon and with CO2H, and this carbon is with one hydrogen. So same molecular formula, it means same number of carbon, hydrogen and oxygen, the only difference in the structure. It means this pair is having the isomeric product. If we heat this, what will happen? Cyclization will occur in between this carbon and this carbon, and it will give the product of this. The CH2 becomes substituent, and over here is double bond O. Whereas when we heat this, what will happen? OH from this carbon atom and hydrogen from this carbon atom will remove, and we will get CH3, C double bond CH2, and this carbon is with COOH, that is CO2H. So same molecular formula, same number of carbon, oxygen, hydrogen, the only difference in hydrogen structure. It means this pair is also having the isomeric product. So the answer is option D, all of the above. Okay. Thank you.